We present supplementary material for our work Cook2LTL, translating cooking recipes to LTL formulae using large language models. Here, we describe a step-by-step example of a simulation rollout for a recipe from our dataset. The input is the natural language instruction step, chop the tomato and bread with a knife. We first convert it to a function representation consisting of the verb chop, the phrase the tomato and the bread, corresponding to the what category, and the phrase with a knife, corresponding to the how category. We detect the word and in the what chunk and write down an initial formula phi with the and operator. We then check whether the verb chop is in the primitive action set or the action library. We do not find it in either set, so we prompt the LLM and generate a plan that splits the chop action into two subformulae, psi1 and psi2, of known primitive actions. This action reduction policy is saved to the action library. Therefore, when our system parses the rest of the formula phi, querying the action library for the verb chop is successful, and the action is implemented by reusing the cast plan, replacing the previous parameters with the new ones corresponding to the respective categories. The initial formula phi is then decoded to a final formula that consists of the subformulae psi1 and psi2. This formula can be used for downstream tasks, such as planning in a kitchen environment. Note that we only reuse a cast policy if the parameter types match. This means that if the second concurrence of chop had an additional where parameter, we would have to requery the LLM for a new policy and save that to the action library. We showcase our Cook2LTL system in a simulated AI Thor kitchen environment on a set of 4 simple cooking tasks. Here, we demonstrate the task of refrigerating an apple. We adapt the prompt, example functions, and the set of admissible actions to the environment and follow the pipeline that we described, which yields an action reduction policy and a formula phi consisting of subformulae psi1, psi2, psi3, and psi4. We assume that the kitchen is mise en place, which means that the location of the objects are known to the agent. At runtime, we invoke a minimal parser that receives the final LTL formula phi as input and executes actions based on the LTL specifications in the formula. In this example, the first subformula psi1 opens the refrigerator, followed by psi2, where the agent picks up the apple. In psi3, the agent puts the apple in the refrigerator, and psi4 instructs the agent to close the refrigerator. For quantitative results, please refer to the paper. The code is publicly available on the GitHub repository linked at the bottom of the page. Thank you.